I am Anil Kumar. Welcome to my YouTube channel. Let me thank all the viewers and subscribers for their keen interest and brilliant questions. Here is a request from one of our subscribers who wants to understand the concepts for sequences and series. So, for him, here is a very special series which we have generated. We are going to first discuss what are sequences and series, and then in details look into arithmetic sequence and series. The idea here is to cover the essential skills to master the techniques. If you really want to learn in details, you can always contact me on the email address given here. We can have group classes or one on one classes to understand the concepts better. We'll talk about what are arithmetic sequences and series. I've divided the lesson into main topics. We'll first consider the key concepts. I'll share with you the formula list and then test questions. Now, test questions is something very important. You should know why are you studying this subject, correct? End result is you have to appear in a test, and so you have to score very good marks. That could be one end result. The other result could be in applications. How can we use this information in many different ways? Perfect. So, or real life modeling, right? So that is also an application. So we can take few examples which relate to applications. I'll consider money, where let us say we invest $100 today and then $20 every month. Then, by the end of the year, how much money are we going to have? Those kinds of questions can be taken. As you can say, it is a sequence of events which are repeated over a period of time, and you do get a pattern. So, this could be a part of sequences and series. You get the idea, right? We'll also take very difficult questions which have been in previous test questions or examinations, as you can see here. So, it meets the objective of understanding the concepts to performing at a very good level, right? The test questions which I have selected are from the previous 7 years. So we have knowledge based questions, communication questions, application, and thinking questions. Once you understand all these concepts, I'll share with you another test paper which we are calling as mock test. So you can take this test today, and whenever you have completed or you need my suggestions, you can send the test to me on the email address given for my feedback. So now let's begin. When we say begin, we'll begin with the basics. And my first question to you is what is the difference between sequences and series? Correct? So the question here is what is the difference between sequence and series? Can you tell me? Let's look into this, right? And then we'll begin from here, very basic question, and end where? End with examination style questions by taking up the mock test. I hope you find this interesting and useful. So let's begin. So the very first thing is to understand what is a sequence. Well, you're seeing the numbers. For example, 1, 2, 3, 4, the counting numbers, you can go forever. Let's stop at 100. So we say this is a sequence of numbers starting at 1, adding 1 each time. You could describe it like this, correct? I could have a sequence of numbers like 3, 7, 15, 31, 63, and so on. Well, how do I get this sequence? So slowly it becomes tricky and more complicated, correct? So, how do I get this sequence? You may have to figure this out. Well, let me tell you one thing that in this sequence, the very first term is 3, right? We call this as the first term, right? And this 7 is the second term. We may write like this second term, okay? So there are many terms, right? 1, 2, 3, 4, 63 is the fifth term. In short, we can write this as t subscript 5. So these are common ways of representing each term in a sequence. First term can also be represented by the letter A. So we say sometimes A for the first term. Okay. So A or T1 or first term is kind of same thing, right? Representing the very first term. Now, sequences could go like till infinity. So we have infinite terms here, right? Or we could have a finite sequence. This is finite sequence, the very first one. Since there are 100 terms, you can count them. You get the idea. So what we understand now is that sequence starts with a number, and each number in a sequence has a position, and that position is called the term number, right? So in a sequence we have these numbers, we're separated by comma, and they kind of continue, right? And each is called the term number, right? So we have this as a term number, which in this case is term number 1, and the value which we put here, let's say 1, it is the term value. So the value here is 1. You get the idea, right? So we could say that here this is my term number 3, and T3, third term, is equal to, let us say, 7, right? So we'll write 7 here. That is the term value. So that is how we could actually have a definition for sequence. All the numbers are related to one another. So in short, I can say sequence refers to the terms starting with an initial number. We'll call this initial number as A, and following a rule. All of the numbers which come in this order are related with one another with a rule, correct? So for rule, we have three types of rules. We say explicit rule. So explicit rule tells you exactly what the nth number will be. For example, we can say that the explicit rule for any number is that Tn is equals to 2 times n plus 1. That is an explicit rule. Or we could have an iterative rule. So iterative rule is repetition, as the word suggests. We say, well, if T1, the first term, is, let us say, 1, in that case, Tn plus 1 is related with Tn, and it is plus 5, for example. So you add 5 each time to the initial or the previous number. So you get another rule and another sequence. So we'll basically follow two different rules, explicit rules and iterative rules, to describe our sequence. Well, remember, you can always describe sequences in words, right? So you can describe sequences in many ways, correct? So you had been doing it in words, correct? Or implicit rule, correct? So there were other ways to describe, but we'll more focus on the explicit and iterative ways of describing our sequences. Okay, now here are more examples of sequences. We can say that the first term is 3 and the next term is twice the previous term minus 1. So when I use the term Tn plus 1 and Tn, it means we are relating two consecutive terms. Do you see that? So at this stage, we are relating two terms which are consecutive terms. So the next number which comes is related to the previous term, right? And these are together called consecutive terms. So we have related one term with the other. And that is the iterative rule which I was talking about. So I hope this concept is clear. So in this video, we are touching upon the broad areas of our interest, but we'll mainly focus on arithmetic sequences and series. Now let's get to this series part. So when we talk about series, it is addition of terms in the sequence. You get the idea. So series basically involves addition. So when we have questions based on a sequence, we are trying to find what is the fifth term, what is the hundredth term, what is the last term, right? But when we talk about series, we say what is the sum of first 100 terms? How many terms will be there if the total sum is 1000? You get an idea. So series will involve addition of terms in the sequence. So that is how they are so closely related, and we always call them sequences and series. Sequences is the term separated by comma, and series is these terms added by addition symbol. You get the point, correct? Now let's continue with the summary of our formula. So now let's talk about arithmetic sequence first, and then I'll share with you all the formulae related with arithmetic sequence. So as I said, in a sequence we have a rule to be followed. In arithmetic sequence, the rule is we add the same number each time, right? So that means the difference of two numbers is constant. So arithmetic rule is add same number each time. So that number normally we say letter D, right? Of course, we'll start somewhere, right? So start at number A, right? So that becomes our initial number, and what we are adding is D. So if the common difference is same, so that means we have common difference is same because you add D, right? So it really means that common difference is constant and is equal to D. Is that clear to you? So D becomes the constant common difference. For example, if I have $100 and I keep adding 20 each month, then the number of dollars which will be 100, 120, 140, 160, kind of like this. Do you see that? So 20 is being added each time. So starting number being 100 and D, the number added is 20 to 100. You get the idea. So that is a sequence which will be treated as arithmetic sequence since the terms have a common difference. So a sequence refers to the terms starting with A following with a rule, and when we talk about arithmetic sequence, it has a common difference D between each consecutive terms. Consecutive means terms which come one after the other. Now, when we talk about the arithmetic series, it means addition of these terms, right? And here, there is a very important formula. Since we have added the same term, since we have added a fixed number to each term, we can actually find the average of all these. And we have many questions related with arithmetic mean, right? So let me also share with you the formulae which will be used in solving questions based on arithmetic sequences and series. Tn gives you the value for the nth term. It is equal to the initial value, the first term, plus n minus 1 times d. Sum of first n terms in any sequence, arithmetic sequence, is n over 2 times 2a plus n minus 1 into d. Now this formula can be rewritten or reorganized in a way so that we can relate the sum with the first and the last term. As you can see here, if I write 2a as a plus a, then what do I get? I get a plus n minus 1 times d. Now a plus n minus 1 times d is actually tn. So I could write that second term, second value as tn. So the sum becomes half of number of terms n by 2 times a plus tn. That means first term plus the last term. So average of these two times the number of terms. You get the idea, right? So this is kind of important to understand. So it is saying that we are getting Sn as equal to first term plus last term, right? divided by 2. So that becomes the average, right? And then multiply each with n, the number of terms. So that is another way of interpreting the sum formula for arithmetic series. Perfect. Now let's get into these concepts. Now the very first example which I took is that we have $100 and we keep on adding $20. So what we are doing here is that we start at 100. So A value is 100 for us and the common difference D is 20 for us, which we are adding, correct? So we could write this as arithmetic series where every time we are adding D. So here we add how much? 2 times 20, correct? And then we add 3 times 20, which is 60. So the last term here is n minus 1 times D, right? Can you tell me what is this last term? Can you tell me the term number for this? That is what I'm interested in, right? So of course, we started with 100 and we end with 100 plus 1000, right? So 1000 means how many 20s did we add to this to get 1000? So to get 1000, we added how many 20s? Well, let's divide and we get what? 50, correct? So if we add 20s one time, right? This is one time, right? So when you add one time 20, you get this. So what is this term number? Can you tell me? Is it 50 or 51? Correct? It is T 50 plus 1. Do you see that? So at the end, when you get 1000 as the additional amount, which means you added 50 20s to it, right? So first 20 means second term, right? So this 120 was the second term. When you added D only once, do you get the idea? So now you understand why we have n minus 1 times D in our formula, correct? So you start with the first term, you don't add anything in the first term. That's the whole thing. In the second term, you add once, and therefore we have n minus 1 in the formula. Very important to understand. We have already discussed the sum, but see, this sum can also be seen in many different ways. If I have numbers like 1 plus 2 plus 3 plus 4, let's say plus 5, let's take up to this. This is a series. I could add them in the reverse order. 5 plus 4 plus 3 plus 2 plus 1. So if I do that, what do I get? I get 6, right? Plus 6 plus 6 plus 6 plus 6. We get 6 each time. How many 6 do we get? 1, 2, 3, 4, 5. We get 5, 6 because there were 5 terms. But since we added them twice, so this is sum twice the sum, right? And how many 6s we have? We have 5 6s, correct? So we have 5 6s and therefore this answer will be 30. Do you see how we found this value? So you can see now that n by 2 basically is because 2Sn, you get the idea. So Sn will be equals to, in this particular case, 30 by 2 or 15. You get the idea. So it is half of this value, correct? Now, you can relate with this particular formula where we are saying S of n is n by 2 into a plus t of n, correct? Now in this, we'll take few examples also. If I use this formula for the sum of n terms, which is 1 plus 2 plus 3 plus 4 plus 5 and so on till n, what will be the result? Well, as you can see here, it is n times n plus 1 divided by 2. So as you saw here, it is 5 times 6 divided by 2. You get the idea, right? So there were 5 terms, and when you're adding 1 to 5, 1 plus 5 is 6, so n plus 1, correct? N is 5, n plus 1, 5 plus 1 was 6, and twice that was added, so divide by 2 will give us the sum. So I hope you get the gist of it. How do we get the sum of natural numbers? Now you can work out similar strategies to find sum of even numbers. So if I have sum of n even numbers, in that case I could write my series as 2 plus 4 plus 6 plus 8 plus till 2n. Well, we can take 2 common, and if I do that, I get 1 plus 2 plus 3 plus 4 set of natural numbers inside, and that will be twice the sum of series for natural numbers, and that gives me the result n times n plus 1. So these are different ways of working with the given formula which we have seen. So I hope that gives you a fairly good idea of how to work with these formula, correct? Now with that knowledge, let's start the test. So here are questions which are multiple choice questions. You might need a calculator, not necessary though for most of them. Very first question here is, which of the following sequence is in arithmetic series? Uh, is in earth is an So which of the following sequence is an arithmetic sequence? Okay, so you can work it out. We are looking for common difference. So if you see this, we are going up by 2 and then this is 4. So this is not arithmetic. In this particular case, we are adding 1/4, right? So here again we added 1/4, correct? So again we added 1/4. So this one is the right answer, correct? So that is how you can figure out whether it is an arithmetic sequence or not. So that was a simple question. Now let's move on to question number 2. The question number 2 here is, first term of arithmetic sequence is minus 12 and the common difference is 3. Find the 10th term of the sequence. You can now pause the video, answer the question, and then look into my suggestions. So we are saying first term, which is a, is equals to minus 12. Common difference, d, is equals to 3. We have to find the 10th term. We have to find t10, right? So what is the formula? Well, as you know, the formula is Tn is equal to a plus n minus 1 times d, right? So a is minus 12 for us, right? And we can add 10 minus 1, which is 9, times d, which is 3, correct? So that gives you the 10th term as minus 12 plus 9 times 3, right? So minus 12 plus 27 gives you the answer, right? So 27 minus 12, which is 5, and then we get 15, and therefore the answer for us is B. Is that clear to you? So that is how we can apply the formulas which we know about it and then find the solution. So I hope that is clear. Question number 3 here is, first term of arithmetic sequence is minus 8 and the common difference is 3. Find the number of terms if the last term is 100 in the sequence. So it begins with minus 8 and the common difference d is given to us as 3. The last term, let's call them tn, is given to us as 100. We have to find the value of n, correct? I'd like you to pause the video, answer this question, and then look into my suggestions, right? Well, again, direct application of formula, right? So Tn is a plus n minus 1 times t. We're given the nth term, which is 100 for us. We know the first term, which is minus 8. We don't know what n is, but we know what d is, right? Now we can solve this. So 100 plus 8, right? And we can divide this by 3 to get the value of n minus 1, correct? So when you do 108 divided by 3, we can add 1 to this to get the value of n, correct? So you get what? 3 goes 3 times, which is 9, and 18 is 6. 36 plus 1 is n, which gives you 37 as your answer, correct? So that is how you can find the solution. So I hope you're finding it simpler now, right? Okay, let's move on to another question, which is question number 4 for us. The question here is, find the value of x if x, half x plus 7 and 3x minus 7 are the three consecutive terms in an arithmetic sequence. So we have to find what x is. We are given three terms, which is x, half of x plus 7 and 3x minus 1. You have to find the value of x. We know all of them are in arithmetic sequence, right? Okay, how can you do this? Well, important thing here is that the center term is the average of the two, correct? So you can use average mean, right? So arithmetic mean. So if A, B, and C are three terms, in that case, A plus C divided by 2 is basically B, or you can say A plus C is twice B. You understand? So that is the concept. You can use this concept to find the solution. So let me use this concept. B is the center term, which is half x plus 7. So 2 times half of x plus 7 should be equal to the sum of x and 3x minus 1. You get the idea, right? So let's open the bracket. So we get x plus 14 equals to x plus 3x is 4x minus 1. Now bringing the x's together and the numbers together, we get x minus 4x is equals to minus 1 minus 14 minus 3x equals to minus 15, and that gives you the value of x as equals to 5, correct? 15 divided by 3, so it becomes option B for us. Is that clear to you? So that is how you can answer this particular question. So we have used the formula for arithmetic mean. Question number. Now here is question number 5. The arithmetic mean of two numbers is in an arithmetic sequence is minus 6. If one of the numbers is minus 15, find the other number, right? So let us say we have A, B, C as the three numbers. When we say arithmetic mean is given to us, that means the center number B is given to us, and that is given to us as minus 6. And we also know that twice B is sum of A and C, correct? So that is the information known to us. We are going to use this information to solve the question, correct? So let's solve it. So we have twice the given value of minus 6 arithmetic mean, one of the numbers being minus 15 plus C, right? So we have minus 12 plus 15 equals to C, and that gives you the value 3 for C. And so option B is the right option. Clear? Question number 6. Find the number of terms in a given sequence. So we're given a sequence which is x plus 1, x plus 6, x plus 11, and the last term is x plus 241, right? So let's rewrite this. X plus 1, x plus 6, x plus 11, so on, and we have x plus 241. Can you pause the video and answer this question? Well, we can look into this that each time we are adding 5, right? 1 plus 5 is 6, and then again we are adding 5, right? So we know that term A is x plus 1, and D, the common difference, is 5. And we also know that the nth term is x plus 241, correct? So we can see how many D's have been added. This is one way of doing it, correct? Or we can apply the formula. So we can do it in either of those two ways, right? So if we apply the formula, then what do we have? Well, Tn is basically equal to A plus n minus 1 times D. So in our case, the value of Tn is x plus 241, correct? The value of A is x plus 1, and we don't know what n is. We need to find this, and D is 5. So we can now subtract. So x plus 241 minus x minus 1 equals to, let me write this as 5n minus 5, okay? So we get x plus 241 minus x and x cancel, we get 240 equals to, we can add 5 also to this, right? Bringing this 5 here, equals to 5 times n, or 245 divided by 5 becomes the value of n, correct? So that goes 5 times 4 is 20, and then 45 is 9. So we get 49 as our answer, correct? So that is how we could do it. Alternate method could be, we could find the how many differences, what is the difference between the first and the last term, right? So between this, how many d's did we add, right? So we could do 241, 241 minus 1, which is 240, divided by the common difference, which is 5. You get the idea. If you do that, then what do we get? We get 48, right? Now, the term number is n plus 1. Do you understand? The last term, we have to add n plus 1. So the term number, I should write n equals to, so this is n minus 1, right? So n minus 1 is 48. N is equals to 48 plus 1, which gives you the same answer as 49. Is that clear to you? Correct? So you could actually find the difference between first and the last term and then divide by the common difference. So let me write down the formula here. Number of terms n equals to last term minus first term divided by common difference plus 1. So we have just rearranged our formula and written it in this particular form. So this is a very handy formula to find quick solution to similar questions. Is that clear to you? Here is question number 7. Grade 11 students are contributing at least $12 each to raise the money for supporting the breakfast plan in the school. The class teacher contributes $50. Represent the minimum amount raised as an arithmetic sequence, right? B. Find the minimum amount raised if 24 students contribute. Okay, so teacher contributed 50, right? So we have 50 from the teacher. Now every student is contributing 12. So we'll add 12 each time when the number of students are added. You get the idea, right? So if you add 12, you get 62. And then again, let's add 12. And what do you get? You get 74. And likewise, we can keep on adding 12 each time. Is that clear to you? So that is the contribution for the student, right? So in that case, how do you represent the minimal amount raised as an arithmetic sequence? So if there are two students, then 74 is raised, right? So what we can say is that the minimal amount raised is, which is written here, is term number, which is equal to A is 50 for us plus n minus 1 into D, right? N minus 1 into D, where D is 12 for us. You get the idea, right? So that is all. If there is one student, in that case, we have the first term, right? So those are the number of total people, including the teacher. Now you can check that if there is one student, then 1 minus 1 is actually 0. 0 times 12, you do not get the first term, right? So therefore, we should say that this case, since the teacher is the first term, right? So second term, which is T2, will be equal to what? 50 plus, yeah, let's write like this, 12. So 50 plus, second term is actually one student, right? One student will be 2 minus 1 times 12, and that gives you the right answer, which is 62. However, here you can see student is one only. One student contribution when we are talking about two terms. This is important to understand, right? So, but that is the formula. Is that okay? So it's represent the minimal amount raised as an arithmetic sequence. So that becomes the arithmetic sequence. Now, part B is find the minimal amount raised if 24 students contribute. So, if there are 24 students, then in that case, n, the value of n will be what? Well, 24 students contribute, right? So, we are looking into the term which is if one student contribute, we are looking at that term, right? The second term. You get the idea? So for 24, we're looking at the 25th term. You get the idea? That is critical to understand, right? So it is 50 plus 25 minus 1 times n. So basically, 24 students contribute. That means 24 students contributed $12. And so you get this formula in this particular fashion. You get the idea, right? So that is how we have to write. In terms of term number n minus 1, where n is actually equal to 1 less than the number of students. Perfect? Okay. So let's find this answer, which is 50 plus 24 times 12. So we get an amount which is $338. Is that clear to you? So straightforward also, if 24 students are contributing, each will contribute $12. That is their amount which is contributed plus the teacher's contribution of $50. So it is 50 plus the 24 students. Is that clear to you? Correct? As far as the term number is concerned, each student is actually one more than the term number, right? So Tn plus 1 we have to calculate. Is that clear to you? Tn plus 1. Perfect. Now let's look into question number 8, which is Peter joins part-time job on a salary of 15,000 per year. His salary increases every year by $1,000. After n years, his total earning is 148,000. Find the quadratic equation that relates the total earning for n years, right? So after n years, we don't know how many, it is 148,000. We have to find the quadratic equation that relates the earning of n years, right? So that is the question for you. It is thinking and application question. I'd like you to pause the video, answer the question, and then look into my suggestions. So basically, what we see here is that the Peter joins over the salary of 15,000 per year. Every year, the salary increases by 1,000. So, right, it is 15,000 becomes 16,000. So, A is 15,000, right? D is 1,000. And we want to find the sum is given to us after n years, right? So sum Sn is n divided by 2 times 2a plus n minus 1 times d, right? That's the formula. So we can apply the formula and find the result. Total is 148 1000, right? Equals to n divided by 2, and we have 2a, that means 2 times 15,000 plus n minus 1 times 1,000. Correct. So we can actually cross multiply. So we do 148 times 2, and that gives you 296,000. Or you could divide the inside terms by 2. That is simpler, right? So we'll divide the inside terms. So we have 148,000 equals to divide the inside terms. We get n times first term is 15,000 plus n minus 1 times 500. Is that clear to you, right? So we can now open this bracket. So we get 148,000 equals to 15,000 n minus 500 n square, rather plus 500 n square minus 500 n when you open this bracket, correct? So you can open this bracket multiplying 500 by both these numbers. So you do get a quadratic equation. You see that. Bringing all the terms together, we have 0 equals to, rearrange them, 500 n square plus 15,000 n minus 15,000 and 500 can be combined, correct? So 4,500 n and minus 148,000. Do you see that? So we get a quadratic equation which represents this situation. So that is how we can actually find the solution of this equation, correct? So we have 500 n square plus 140 500 n minus 148,000 equals to 0. So that becomes the solution in the form of a quadratic equation for this question, right? So in this question, we have to only find the quadratic equation. Now, as a part, we can extend this. You can say find n. So you can do this, right? So extend. So I hope that makes sense, right? So let's move on and take the next question, which is question number 9. So it's slightly tricky. Consider the arithmetic series 4x plus 8x plus 12x and so on, the last term being 800, where x is the positive integer and a factor of 100. A. Find the terms of x. Find in terms of x an expression for the number of terms in this series. So first thing is we have to find the number of terms, right? So let's find the number of terms. So how will you do the number of terms? That means n value, right? We know the last term 800 we can find, right? So we have the series which is 4x plus 8x plus 12x plus so on till 800. Now we have to find the last term, the number of terms. So there is a very shortcut method. Let me use that. I can take 4 common, right? If I take 4 common, in that case I get x plus 2x, right? There's no need of comma here. Plus 2 plus 3 plus so on. And 800 divided by 4 is 200, correct? Correct? So let me redo this. Let me write it clearly. So we have 4x plus 8x plus 12x plus so on till 800, correct? I am taking common as, let us say, 4x. If I take 4x common, then we have 1 here, right? Plus 2 plus 3 plus so on. Here what is common? 800 divided by 4 is 200 and divided by x. Do you see that? So we get the answer A as the right answer for the number of terms. First term is 1 in this case, right? We got 1, 2, 3, 4 to 200 over x. So the number of terms n basically is equal to 200 over x. Is that clear to you? So the first term n, total number of terms, is 200 over x. Perfect. Here is question number 10, which is based on the previous question. It says the same thing. Consider the arithmetic series 4x plus 8x plus 12x till 800, where x is the positive integer and a factor of 100. Find the sum of the series in terms of x. So now we have to find sum of the series Sn, right? We already know that n is equal to 200 over x, correct? Or you can use 800 as the last term also. So we can use the formula, which is half of first term, right? Plus the last term we can use this formula, right? So first term is 4x, so we can say half of 4x plus 800. So that can give you times the number of terms, right? Times n, times the number of terms, correct. So that can give you the result. We know what n is. N is 200 over x. So let me just substitute this value. So if I multiply by half, I get 2x plus 400, and the value of n is 200 over x, correct? So when we expand this, 200 times 2 is 400, x and x cancel, plus 200 times 400 is 8, 4 zeros, over x, correct? So we get option B as the right option. So you could do it in this fashion also. So we already know how many terms are there, apply the formula, get the result, and that is how you could do it. So I hope with this you have understood different ways of solving these questions. We have more questions to do, but I'll take them as an assignment. So here is question number 11, which is thinking and application question for you. If b plus c minus a over a, c plus a minus b over b, a plus b minus c over c are in arithmetic sequence, then prove that 1 over a, 1 over b, and 1 over c are also in arithmetic sequence. Well, the hint is something like this. We have b plus c minus a over a, correct? The other term here is c plus a minus b over b, correct? And the third term is given to us as a plus b minus c over c, correct? So these are the three terms and they are in arithmetic sequence, correct? Now, if you add same number to each, they still remain in arithmetic sequence. So let's add 2 to each. What do we get? If I add 2, we get 2a, right? We get b plus c minus a plus 2a over a. And this becomes c plus a minus b plus 2b over b, a plus b minus c plus 2c over c, correct? And that gives you a plus b plus c over a, right? I'm rearranging and writing like this. Here also, we get minus b plus 2b is b, right? So you could write this as a plus b plus c over b. And this can also be written as a plus b plus c over c, correct? And now you can divide everything by a plus b plus c, right? So if I divide everything by a plus b plus c, I get 1 over a, 1 over b, and 1 over c, and they should also be in arithmetic sequence. Is that clear to you? So the idea here is that in arithmetic sequence, adding same number or times or divide by same number makes no difference. Do you understand? Keeps arithmetic sequence as an arithmetic sequence. That is the key here. So that is what we could do to get the solution of this question, right? So I hope you find this very interesting. Now here's question number 12, which is again a very tricky problem, which is let a1, a2, a3 be in arithmetic sequence, and if the quotient, which is a1 plus a2 plus a3 and so on till ap, divide by a1 plus a2 plus a3 plus ap till aq is equals to p square over q square, where p and q are different, then find the value of a5 over a11. That's the question for you. Now that's a very difficult question which has been seen in test questions. I'd like you to pause the video and answer this particular question. How can we do it? Well, on the top we have some formula, right? So this is, we can say, s of p terms and this is s of q terms, right? So let's write down. So what is the ratio? And that is equals to p square over q square, right? So s of p will be what? P over 2 times, first term is a, twice a, right? Plus p minus 1 times the common difference d. And we are dividing this by S of q, right? Which is q over 2 times 2a plus q minus 1 times d, right? So that is the ratio. And this ratio is basically equal to what? P square over q square, right? Okay. So you can see that this 2 cancels with that 2, and this p over q cancels with one of the powers. So what we basically have here is that 2a plus p minus 1 times d over 2a plus q minus 1 times d is equals to p over q. So we get that relation simplified, correct? Now, let's also figure out what is a5 over a6, a11 equals to, right? It's kind of small. Okay, so a5 basically is a1 plus 4d, right? And 11th term is a1 plus 5d. Is that clear to you, right? But what we really want, how can we relate these two? How can we relate this? We got 2a here and a here. So what I could do is I multiply all this by 2. Then I get 2 times a1 plus 8d, right? And here I get 2 times a1 plus 10d. Now if you relate, p minus 1 should be equal to 8, q minus 1 should be equal to 10, and then that ratio will be p over q, correct? So that is the idea. So we have p minus 1 equals to 8, and that gives us p equals to 9. And we have q minus 1 equals to 10, and that gives you q equals to 11, right? And therefore, we have this ratio p over q, which is 9 over 11. Now q was 11, right? Sorry. Q was 11, so this is 10, not 5. Sorry. We want A11, right? So it is 10d. So this will be 20. So Q will be 21. So we get 9 over 21 as A as our answer, right? It's very small. It is, let me enlarge this a bit, right? So we are trying to find A5, we are trying to find A5 over A11, right? Therefore, we get this term, which is 10. Is that clear to you? So we find this particular answer by relating. So I hope that makes sense, right? So we'll kind of end our session here. We have an assignment for you. I'd like you to pause the video, read this assignment. You can always answer and submit your solution to my email. We actually have many more questions for you. We'll actually close the video here, and I'll share with you many other questions which are there in this particular video. We'll look into some sessions, let me share with you the mock test. Okay, so here's the mock test for you. So at this end, I like to share with you the mock test. I hope you're prepared for it. These are few test questions which you can try and then send me the solutions, right? These are all multiple choice questions. 5 of them you can see on the screen. Answer them. And then we have 5 more. You can pause the video, answer these questions. Correct? Then we have a application question which we did, right? We did this question number 12, which is again repeated here. And well, these are the solutions which I can share with you once you submit your solutions. Is that clear to you? Perfect. So we'll end this session here. I hope you have understood in short what is arithmetic sequence and what is arithmetic series, how do we solve problems related to them. We had many practice test questions for you. I hope that helped. If you go to my website, you will actually find all these questions. You can actually practice many more questions from my website related to any topic of your interest. And if you need my help, you can actually call me or send me an email on the address given here. That should help. I'll also provide you a link, that'll be better, for with my student, Amy, where we are discussing many more questions which are examination based, EdXL UK based examination, and they may also help you a lot. With that, I'll close the video here. Thanks for your participation and all the best.